Hello, Fun. My name's Nick, and I'm here at the World Championship in Houston with Team 4613 Barker Redbacks. They've had a great season so far, serving as the champions of the Southern Cross Regional, with a great robot to boot with this giant arm that does it all. Come see all this and more coming up on Behind the Bumpers. Now we're going over to Rory to talk about their arm and climber system.
Yeah, so at the very beginning of the season, we were faced with a pretty difficult choice between trying something new, like an elevator for us. Like, we haven't done an elevator in a few years, but we did do an arm in 2023. So we kind of followed on with that sort of idea, and we decided to do a double jointed arm. So using gears to power the first stage, just like milled into some 12.7 millimeter aluminium, and using belts all the way from the bottom with the max planetary gearboxes. And that drives the first joint with the gears, and then this max planetary into the belts for the second stage. And we use those gears and belts mainly just to reduce backlash. And yeah, moving on to the climber system, it's also integrated with the arm. So as you can see, we have like just these guides to guide the cage into the wheels, and then the wheels, once they hit the limit switch, the robot will automatically climb with the cage like intact. Yeah, and like as well as the climber, we also have the intake and the ball shooting system all mounted onto the arm, and that's more like, it adds to the modularity of the arm like as a system, because we can just add more subsystems on. So from our regionals, we had just like a passive ramp at the very beginning of our intake, and now we have like more systems like the ball shooter and the intake, the ground intake on like actually on top of our arm. Yeah, so we'll go through a few different positions that the arm can go to, just to showcase what it's capable of. Yep. All right, ground intake. Yep. And then it automatically goes to this position, which is like the has coral position. Then to score. And then back to this position. And this is our human player position if we were to not ground intake. We'll also have a ground algae position. Do you want to do algae? And then from there we can shoot. Yeah, just all good. Yep. And now Corinne,
Yeah, thank you, Rory. Actually, one thing I'm curious about, did you have any particular difficulties making all this packaging work? It's really cool and really slick now, but it feels like it could have taken a lot of work to make it all fit together.
Yeah, so in CAD, we kind of put the CAD of the robot on the field and see if it's actually going to work. So a lot of this geometry takes like a few different iterations where we put different versions of the robot on the field in CAD and see like what actually has a better measurement for scoring level 2 and level 3. And also like what can go from the ground to a shooting position and stuff like that. And all of our subsystems are kind of mounted in a way that it can reach all of the positions that we want to get to.
Thank you very much, Rory. Now we're going over to Corinne to talk about their automation and interpolation.
Yeah, so building on what Rory said about the arm, we have 2 limelights. So we have one on each side, which maintains that we're able to always see an April tag when we're scoring on the reef. And we also have can ranges next to them. So what we do is we are able to detect how far away we are from the reef, and from that we're able to adjust our arm, so we're able to score from, for example, if there's 1 coral between us and the reef, or if there's 2 corals, so our arm is able to automatically adjust for that. Another thing we have is from our limelights, we're able to update our position on the field, so we're also able to do other automations. For example, always look at an April tag when we're scoring algae or at the human player station. One thing about our autonomous, which is quite unique, is that we score 1 coral and remove 3 algae from the reef, which also puts us at an advantage when we start teleop, because our alliance partners are able to start scoring from the back of the reef where there's no algae already, while we remove the front algae already.
Thank you very much, Corinne. Now we're moving over to Toby to round it out with their chassis and intake.
Yeah, so as Rory mentioned earlier, coming out of regionals, we kind of looked at our robot with the passive ramp and decided we wanted to implement a ground intake in order to allow us to score more efficiently, really just looking at all the other robots on the field. So we use these West Coast Products star rollers to help kick the coral in, and then launch it into these polycarb funnels on the side, which help direct it into the center of the intake. Then moving on, it's able to go out through here and onto the pole. As Corinne mentioned, with interpolation, this helps us score at a variety of angles, meaning that we don't have to be too fussed about aligning perfectly perpendicular to the pole. This has been really helpful in scoring in a fast and efficient manner and really being a vital part of each alliance. Additionally, with our autonomous, we have the algae input here, so we also added a single-use preload scorer on the side. This allows us to score that first coral in autonomous and reach that auto bonus every time. With the intake, it's all machined out of 7075 aluminium, so that helps us proc it really heavily to bring the weight down, as it is on the end of the arm, and we have to be really conscious about that in order to make the subsystem work well. So as you can see here on the algae shooter, it's really heavily pocketed, which allows help bring the center of gravity down. Yeah, and then with our chassis, we once again decided to go with the billet chassis. We found the billet chassis as a really effective way of designing our chassis every year, providing a robust and reliable solution that really never fails on us. So it's a single block of 5083 aluminium that measures 600 millimeters by 680 millimeters in dimension. With this, you'll also notice the way we mount our battery here. We design our battery plate especially to lock the SB50 connector in place to really, once again, as I mentioned before, achieve the aim of getting a really reliable match every single time in regards to our chassis. I guess one thing else with the intake is how we score processor. So we're able to lift the arm up and then intake the algae under here and then shoot that into the processor to allow for a really quick cycle time every time. Yeah.
Thank you very much, Toby.
Thank you.
Well, thank you, 4613 Barker Redbacks. It's been great seeing you here. Great seeing you represent Australia here in Houston. Wish you the best of luck in these final little hours of the qualification round. Best of luck tomorrow in alliance selection and eliminations. Thank you so much for your time.